Welcome to my digital class. In this video lesson, we are going to understand chapter probability. What do you mean by probability? Probability is nothing but the chances of any event to happen. Normally, we call the percentage. What is the percentage that you will come to the school tomorrow? What is the percentage that will go to shopping? What is the percentage or chances that it will rain today? And what are the percentage chances that you will pass the test? And I think there's a 90% chances that she will top the class or he will top the class in the mathematics marks. So what are the chances that you will get 99 marks in the final examinations? So these are the chances we talk about in our daily life, but this made the calculations of chances to be precise and started using in different fields. Normal example, if I would like to tell, in elections, just before the elections or after the election is done in a democracy by voting. So before the actual result is announced, exit polls are coming. Their media persons are telling that X person is going to get this many percentages of votes, and Y person is going to get this many votes, and Z is going to get this many votes. How they have done this type of calculation based upon the calculations done on the probability. So just we here we know there is a chance if we talk orally, but there is certain type of calculations to tell exactly the number. What is the percentage they are going to get? There is a calculation type, so we need to learn that calculation type of probability. Moreover, if you see the weather report in your mobile phones, or Google will say that tomorrow is a 40% chances to rain, and sometimes they have very strict orders from the government will come that fisherman, please don't enter the ocean because high winds are going to blow, and very heavy rains are going to occur, hurricanes are going to occur, otherwise the cyclones are going to come. So there are high chances of cyclones, so please don't enter the fisherman don't enter to the ocean. How they have decided? Because there are certain type of calculations to come to the conclusions. So here we are learning the calculation type of things to tell correct probability. What do you mean by probability? The chances of event to happen. So let's move to the chapter and study the introduction and each and every terminology used in this chapter. Let's go to the chapter now. So here is the probability, and the probability type of questions which we have just listened. It will probably rain today. What is the doubt that he will pass the test? She will pass the test. Like this, the questions are there. There is a 50-50 chances of India winning a toss in today's match. Okay, so these type of words we come across. So now what we are going to do? We are going to learn about probably is nothing but probability, the chances calculation we are going to do. And in the 9th class itself we have learned about to calculate the chances, the probability, and there the definition for the probability was in this way. So in 9th class we defined the experimental or empirical probability, and the probability of an event means the chances of any event. So what is an event? It is it is an outcome, one or more outcome, one or greater than outcome of an experiment. So what do you mean by experiment? What do you mean by event? Just we are going to cover. So this is a 9th class definition where probability of any event was number of trials in which the event happened divided by total number of trials. So here the probability is calculated with the help of trials, means we are doing experimentally and seeing the things. So this is called as experimental or empirical probability. So for example, if we are tossing a die, so there is a rule that you toss the die for 20 times and collect the all outcomes. One occurred how many times, two occurred how many times, three occurred how many times, four occurred how many times. Calculate, tabulate, then calculate. So here it was the example of that. See here, number of times a die is thrown. So this type of experimentally we are noting then calculating. This type of calculations of probability is called as experimental probability or empirical probability. Number of times a coin is tossed, 10 times we are tossing a coin and noting each time head occurred or tail occurred. If we got a head and tail, we are noting down and then calculating about the probability of getting a head and probability of getting a tail. So this type of calculation is tedious process, time consuming, and it is very lengthy. It takes some moreover this type of calculation can be done only for the coins and dice. For example, if we are having one die experiment, okay, we can do, but if we are doing an experiment of two dice, it's get still very difficult. If we are doing an experiment of coins tossing four at a time, then again it becomes very difficult for experimentally to do it. Therefore, we want another approach that is called as theoretical approach. So we already know what type of outcomes you may get when you are tossing a dice, okay, ludo die, otherwise tossing a coin, or you are selecting a day from the week. You already know what type of outcomes you may have. So we are slightly moving away from the experimental approach and going into theoretical approach. So now we are having a theoretical approach formula of probability. This is also called as classical probability of an event is given by number of outcomes favorable to E, or number of favorable outcomes by total number of possible outcomes of the experiment. Okay, so this is the formula we are now going to use from now. This is 10th class formula, theoretical probability, and the previous one which we have learned is the 9th class formula, that is experimental approach formula of probability. Number of favorable outcomes by total possible outcomes. Now let us discuss the vocabulary and terminology normally used in the chapter. Experiment in probability theory. In our chapter probability, what do you mean by experiment? Any work which we are doing which will give us outcomes is called as experiment. So examples of experiment are tossing a coin, throwing a dice, selecting a day from a week, okay, selecting a day from the days of the year. For example, you are having a sag. In the sag means thyla. In that, so many balls are there: red color, blue color, black color. Selecting randomly any ball, so surely you will get an outcome. You are having a money in your pocket, putting a hand and taking out some money will come out. An experiment. You are having a piggy bank, ghalla. So you are doing up and down so that any coin will fall down. It is an experiment. So experiment here means any event, any work which give us an outcome. Okay, what do you mean by event? Event, outcome, when we see number of possible outcomes of the experiment, any selected one or two or more outcome is called as event. Sometimes that will be favorable to me, sometimes favorable to some other. So events are according to the favor we calculate the probability. What do you mean by equally likely? If the outcomes have same probability, then they are called as equally likely. Example, tossing a coin. There is a equal chances of getting a head and equal chances of getting a tail. If you tell the probability after doing calculation, so many calculation in trial method also, you will get approximately 50-50 chances. 1 by 2, 1 by 2. Yes. So therefore we are using this tossing a coin as a fair game to start the football match or cricket match, because it is having equally likely outcomes. Okay, what do you mean by mutually exclusive events? Mutually exclusive event is nothing but two events are mutually exclusive if they cannot occur at the same time. If they cannot occur at the same time. What the examples we are taking about now? The tossing a coin. Head, either head will occur or otherwise tail will occur. If you throw a dice, either 1 will occur, either 2 will occur, either 3 will occur, either 4 will occur, either 5 will occur, either 6 will occur, one at a time. There is no jointly occurring scenario. Non-mutually exclusive event, for example, if we are selecting an event in this fashion, two events are not mutually exclusive if they can occur at the same time. How they can occur at the same time? Our experiment is like this. We are tossing a dice, an event of occurring an odd number and a prime number. Odd number or prime number. For example, if you select this event, you got a 3. 3 is odd, also it is an prime number. So here they are jointly occurring. Therefore, this experiment, this particular event is not mutually exclusive. You got another vocabulary word which we are using here, independent event. Two events are called as independent, that if A occurs and the A's probability will not affect the B's probability. For example, you toss a coin, you got a head, and there is a probability of getting a head. And next time when you toss, again it will be a fair game. Previously you got a head, but now it will not affect tail. So every event will not depend on other and previous occurring also. So these are dependent event. So here what happens, one occurring will affect the next time. For example, you got a sack, in the sack you got so many balls, 5 red balls and 3 black balls. Okay, then what you're doing, first of all you are selecting a ball from randomly. Okay, you got a black ball, you're keeping aside. Next time again you are putting a hand and taking a ball from inside. So what is going to happen there? Next time when you are taking out the balls, there is a reduction in the number of balls, so probability is going to change, and the change is because the previously you got red or black. It depends on the previous result. So here this type of event is called as dependent event. This is dependent on the previous, and in the previous, whether it was red or whether it was black, it depends upon the color also. That is the case, dependent event. Okay, so now we are going to learn so many experiments and want to collect all the possible outcomes of the experiment. This is very crucial. We need to understand different experiments and what possible outcomes is going to get. We have to note down, because in our problems of probability, any event name will be given, but we have to know how many possible outcomes will be there for that event. So in the prerequisite and introduction, we are learning all the different types of events. So we'll start from the coin. Already tossing a coin. A coin means one coin. So sample space is nothing but collection of all possible outcomes. We are writing what you will get, and collection of all possible outcomes is called as sample space. So you may get head and you may get tail. This is a sample space for one coin. Okay, let's write for 2 coins now. Tossing a 2 coins. Tossing tossing 2 coins, or 1 coin, okay, 2 times. they give same sample space. Tossing two coins like this, or you're tossing one coin again two times, the same sample space you will get. So we'll write here sample space. You may get two heads, first time head, second time head, or one head. You may get like this, head and tail. You may get tail and head. You will get tail and tail. Okay, let's continue with our sample space. Let us write a sample space for three coins tossing three coins at a time, or one coin tossed three times. Okay, when we toss three coins, what will be the possible outcomes? All possible outcomes, you will get head, head, head. You may get like this, head, head and tail. You may get like this, head, tail, head. You may get like this, tail, head, head. Otherwise, if you just transpose H with T, you may get like this, T, 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 or T, T, H, or T, H, T, or you get H, T, T. All possible outcomes are 8. So by seeing these three examples, we can conclude that in the first, if we are tossing one coin, how many outputs we got? 2. And if we toss two coins, we got output 4, total possible outputs. And when we toss 3 coins, we got total possible outcomes 8. How did you get this one? Because we are tossing a coin has 2 outputs, so head and tails 2, and one coin is written as 2 power 1 and 2 power 2. 2 coins, so we got like this, and 2 power 3 is equal to 8. So by seeing this scenario, if 4 coins are tossed, then total possible outcomes will be 2 power 4, that is 16. So what will be all the 16 possible outcomes? You can write systematical way, edge, 4 times, then 1 T you are introducing, you are changing the T position, then you are introducing 2 T's, then 3 T's, then 4 T's. So you please do this work. By seeing this, you can imagine if we are tossing 5 coins, then what will be the possible outcomes? By counting HHH 5 times and introducing T, in that way we cannot tell how many outcomes are going to come, but here we can tell with the help of this formula, 2 power 5, exactly 32 outcomes are going to come. Well, so these are the possible outcomes for the 2 coins. Now let us go for 3 coins. Sorry, I'm sorry. Let's go for dice. Let's go for dice. One die is thrown on 3. Okay. Possible outcomes are sample space is 1, 2, 3, 4, 5 and 6. So you should know what is dice. Dice is nothing but just a cube structure where 1, 2, 3, 4, 5, 6 are number are written, which we play in the games. For example, Ludo game or some other games. We throw the die, something will come on the top, that will be considered. So in this way, dice, one die is thrown, we get a 6 sample space. If 2 dice is thrown, what will happen? Sample space will be in this fashion. Please note down. You may get 1 and 1. Both the dice 1, 1. And you may get 1, 2. You may get 1, 3. You may get 1, 4. You may get 1, 5. You may get 1 and 6. Similarly, you get 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 and 2, 6. Similarly, you can get 3, 1, 3, 2, 3, 3. All the sample space in this fashion, when we write, we can answer the questions which are asked in the questions. Okay. So 4 comma 3, 4 and 4, 4 comma 5, 4 and 6, 5 1, okay, 5 2, 5 3, 5 comma 4, 5 comma 5, 5 comma 6, 6 comma 1, 6 comma 2, 6 and 3, 6 comma 4, 6 comma 5, 6 comma 6. So in this way you get a sample space for two dice thrown at a time. By using this formula, we can dice is having 6 faces, one die is thrown, you will get total 6 outcomes. If 2 dice are thrown, you will get exactly 36 outcomes. If 3 dice are thrown, you will get 216, that is 6 power 3. 3 dice are thrown. So how you will write that particular case? So this is very difficult to write all the 216, but what we do here, this is all the possible outcomes for 2 dice. Here 1 2 3 4 5 and 6 will introduce. For 3 dice, for example, we are taking 1, so every one, with this one all is 36, with this 2 all is 36, with this 3 all is 36, can be written like this, 1 comma 1. So everywhere 1 I am introducing in front, then 36 you will get. In the front I will introduce 2 with all this 36, you will get again more 36. In that way total 216 possible outcomes you will get. So hope the possible outcomes for the dice is known. Let us understand what the possible outcomes for the cards. Rummy cards is in this fashion. We will get normally 52 cards. Basically they are divided into 2 parts. Those are 26 and 26. 26 cards are red in color and 26 cards are black in color. Why do we have these 26 basic divisions? And the basic divisions are further 2 groups are there, 13 and 13. You will get 13 hearts. What we got? Hearts. Okay, 13 are hearts and 13 are diamonds. Okay, so, and moreover, if we divide the black, again there will be 13 groups. One will be spades and other will be clubs. If you see, hearts will be in this shape in red color, diamond will be in this shape and red color, spades will be in this shape, okay, and clubs will be in this shape. Okay, so each and every, these are groups, these are suits, hearts, 13 hearts are there. These 13 hearts are divided in further in this way. First card is my ace, then second is king, queen, jack, then you get 2 3 4 5 6 7 8 9 and 10. If you count how many, 1 2 3 4 5 6 7 8 9 10 11 12 13, these are 13 cards. Note that you don't have one. Note that you don't have one. You don't have one. What do you have then? You have in the place of one ace, one ace written, king, queen, jack, and this way. Similarly, 13 are there in these diamonds, and the same 13 type are there in spades and clubs. So you need to understand about the hearts, and that this in cards, king, queen, jack, these are called as face cards. Face cards. Okay, and rest are the number cards. This is ace, this is not a face card, not a number card. Got a king, queen, jack face card. How many face cards are there? In one group, 3 face cards are there. If we collectively see all the face cards in all the 4 groups, 3 face cards are here, 3 face cards are here, face cards. So here also 3 face cards are there. So totally you will get 12 face cards. Okay, and You must know how many kings are there completely. Each suit is having one king, so hearts king, diamonds king, spades and clubs king. So four kings are there, four queens are there, four jacks are there, four aces are there, and rest are number cards. How many number cards are there if you count for collectively from here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, completely 9 cards are number cards. Among them, some are even, some are odd. Everything will be possible. According to that, questions may be asked. Okay. These are the this complete information about the cards. 52 cards are there, 26 red cards, 26 black, and 26 red cards are hearts and diamonds. Blacks don't have hearts and diamond. And then blacks 26 are divided in spades and club. We don't have red spade and red clubs. You do have only red color hearts and diamonds. Okay, so each heart is divided again 13 ace, king, queen, jack, 2, 3, 4, 5, 6, 7, 8, 9, 10 in that way. So let's proceed with more knowledge about sample spaces. In the similar fashion as we have written for the sample spaces for the two dice, let us imagine the two friends went to the shopping. And what is the probability that they went on the same day and different day? These type of questions are asked. So we have to write sample spaces for the days. So the sample spaces for the days of the week. Okay, how it will be, see here, if we are writing sample space for that, it will be in this fashion. Monday and Monday, two friends went, can be both went on Monday. First friend went to the market on Monday, second friend also went to the market on Monday. It can be Monday and Tuesday, it can be Monday and Wednesday, it can be so on. In this way, collectively, if we are writing it a lot, you will get Sunday, Sunday. In this way, if we collectively write completely, this will be Monday and Sunday. And at last, if you are continuing with the Tuesday, Monday, Tuesday, so on like this, at last you will get Sunday and Sunday. If you think about how many total sample space possible outcomes are there, there are 49 possible outcomes. How they became? Because a week have 7 days and the two friends are going. So therefore, if we are thinking about in this format, then you'll get a 49. If you count, also you'll get a 49. So 49 outcomes. For some problems, they tell that Sunday is a holiday, they cannot go to the market, or for example, they tell Saturday and Sunday is a holiday, so they cannot go to the market, or Monday is off, they cannot go to the market. So actual for the week, completely sample space will be that, and holidays you should remove, then rest will be your sample space. From that you need to answer the questions. Okay, so the art was a case for year, and you must know about years. Okay, okay, you do have normally leap year and non-leap year. Okay, non-leap year will have 365 days, leap year will have 366 days. Among them, the questions will be asked about how many weeks are there, how many Sundays can occur, how many Mondays can I have in the leap year or non-leap year, in that fashion. So that type of questions can be answered in this format. If you are having 366, that is a leap year, you are dividing with 7, because in a week 7 days are there. If you completely divide with 7, how many weeks you will get, that you will get. Then you see here, you are actually getting 52 complete weeks. Rest 2 days are there, and if that 2 days to be Sunday, or then the probability will be 2/7. Probability of getting 53 Sundays, okay, in leap year. So you are having only 2 possible days. In among them, you have only 2 days are left, and the total possible days are 7, so you will get like this. So this is the scenario you must know about the leap year, and if you are doing same calculation for the non-leap year, you will get 1/7 at last. So if a question is, are 52 Sundays, exactly 52 Sundays are there in each and every year, and 52 Sundays and 52 Mondays, so answer will be 1 there. And if he is asking about 53, then problems or probability will occur. Rest, let us now calculate about probability of E and probability of not E. What do you mean by not E? So for example, I got a dice, I am rolling a dice. 6 possible outcomes are there, 1, 2, 3, 4, 5, 6, and I am asking that probability of getting, for example, here I am talking about 2. So how many 2s are there here? If we count out 2 number of 2s are only 1, the total possible outcomes, this is the formula type, you'll get 1/6 answer. But I'm talking about not getting 2. Not getting 2. This word I want to explain about not getting 2 is how many possible outcomes are there where you don't get 2. You don't want this one, then I want this and this. So possible outcomes are 5, total are 6. So in this way, by counting also we have done, or otherwise you can go not 2 is equal to 1 minus probability of getting 2. Yes, so 1 minus getting 2 probability was 1/6, and if you do here cross multiplication and you rest again, you will get the same answer. So from here we'll bring a formula. Probability of not E is equal to 1 minus probability of getting E. E is nothing but an event. So if you transpose from here, probability of E plus probability of not E is equal to 1. This is called as complete probability. That is, if you are adding all the possible probabilities of all the events, then you will get answer 1. So rest, let us proceed, and we must know that probability of any event will never be greater than 1, and it will never be less than 1. That is only the case where the probability is different than the percentage. So now I want to explain about percentages and probabilities. Percentage, probability. Probability lies between 0 and 1. So percentage lies between 0 and 100 is not correct. So percentage can be 200%, 300%, 400% also. How do you get that? So in one scenario, percentages will become greater than 100 also. Example, X person salary was 1000. Because he's a very good man, hardworking and clever and helping the company very much, they increase the salary to 7,000. So what is a percentage increase? Percentage increase in salary is now increase value by original value into 100. If you go in this way, 7 increase value is how much is increment? Increment is completely 6,000 increment. So 6,000 increment divided by 1,000 into 100. If you cancel, you'll get exactly 600% increment is there. That is the case. If you convert the 600 percentage into fractional value, you will get a greater than 1 value. That is here the percentage is going to be different than the probability. That is why this chapter probability is introduced in a separate manner. Normally, if the percentage is less than 100, it is same like probability. But when the percentages are greater than 100 sometimes, so we cannot consider it to be a probability. Here comes the difference. Let's move to the problems now. Let's start exercise You're most welcome to start the exercise now.